So we're actually, here on day one, we're going backwards a little bit into first semester before we move ahead with things. This is a whole unit on polynomial work. And so, again, before we can get to the polynomials, many, we have to deal with the monomials one. And you're like, Hardy, I've seen these before. I have. Yeah, we have. We saw it a lot that last month. But before we get there, again, a monomial just means there's no plus or minus involved. So, like, we can have numbers, we can have variables, we can have numbers and variables. But notice, no pluses, no minuses, anything like that. And so, when we're dealing with monomials, we're going to use our exponent rules to fix them. So, for instance, I'm going to go from abstract to real. So if I do the abstract, you're like, nope, Hardy, done, finished. Don't be done. Because I'm about to put one with numbers right after it that'll help if you're not sure. Anybody remember what we do with the exponents when we multiply? Add them together. Okay. Now it has to be the same variable or the same number. It has to be the same base. So if I'm doing this, and let's say we're doing it with variables. So like if I have like x squared times x to the 7th, what would that equal? X to the 9th. Okay, because I just add my exponents up. Nothing bad. Okay. Power rule, I almost like to call the power rule the parenthesis rule because it's kind of what it is. It just means I've got something in parentheses and I'm taking it to an exponent on the outside. That's what our power to power is going to be. So when we do power to power, oh, thank you. What are we going to do the exponents this time? Okay, another name we might use starts with M. Multiply. Okay. So let's go back to the well with 2 and 7 here. So if I had x squared to the 7th power, we just multiply those two together. Okay. So you're like, all right, Hardy, so multiply we add and power we multiply. Yep, good start here. Again, it's just getting used to those rules a bit. Okay, quotient, fancy word for divide. What do we do with the exponents when we're dividing? Subtract. Now, we talked before last semester about how it may not always be top minus bottom, numerator minus denominator. Sometimes we may do it the other way, depending on where the bigger number is, but we'll tackle that as we go. So if we had x to the 7th divided by x to the 2nd, we just subtract them and get our answer that way. And then the last two, I guess I shouldn't call them the easiest, but I kind of like to because they kind of are. The negative exponent rule, which just basically says if we have a negative exponent, we're going to go flipping. So if we have a negative exponent on the top, and we flip it down to the bottom, it becomes positive. So for instance, if I have x to the negative 2nd, technically that's on top of my fraction. So I do 1 over. But if, let's say I had 1 over x to the negative 7th, if the negative's on the bottom at the start, you can just flip it up to the top of your fraction and do it that way. It works both ways. So we've got to keep an eye out for that. It doesn't mean that if it's in one area, it always has to be one certain way. And then my personal favorite, the zero exponent rule. What does anything to the 0 power equal? Close. Thought I heard it. Nope, not 0. Just 1. So no matter what it is, even if there's multiple things going on there, 7x squared to the 0 is still 1. So those are the rules to play with. And again, we get to use these on the summatives and stuff. So as long as I get a little bit of practice, I've always got this to lean back on if I need it. So I'm not going to go bonkos crazy here because, I mean, we have seen some of this before, but I do want to do a few here to kind of get the idea of what's going on. So I think what we're going to do, we're going to hand select a few here. Hand select. Ooh, fractions. Fractions are never fun. I'm trying to make sure we hit. Ooh. All right, let's do this. We'll do like halvesies here. Okay. So let's see what we got here. So we're going to start at 2. First job. If you ever have parentheses, that needs to get taken care of first. So this 2 is going to go to the -2. It's going to go to the 3. And it's going to go to this b. So let me get out of there. So I have -2 to the 2nd power if I need some help there, especially with the sign maybe. I get my 4. And on the rest of these, since we're going power to power, we're going to be multiplying them. So 3 times 2. And then here, since there's not a number, I still can distribute the 2 to it. It's like there's a 1 there. And I can get that done. And you're like, Hardy, there's nothing I can do on the second one. You're right. So I'm just going to rewrite that for the moment. No parentheses. It doesn't have to have anything fancy done. And so now to finish, I got to use my rules. Now I want to mention a couple of things. First, if something doesn't have an exponent, there really is an exponent there. It's 1. And the second part would be big numbers, 4 and the 8, don't play by little number rules. I'm still going to multiply the big numbers. So 4 times 8 is 32. But I will follow the rules on the rest of them because they're exponents. So the product rule says we're going to add them. So 6 and 1 on my A's is 7. 2 and 9 on my B's is 11. And we're ready to rock and roll. So we got to have a little bit of patience in here, but it's not going to be anything that's too bad. Now this next one looks like it's going to be awful. It is not. I'm going to kind of ignore this non-fraction part for a minute here. So let's kind of cover that up. So here I look, and I'm like, okay, no parentheses. That's nice. What's 54 divided by 3? 18. Subtract your exponents. 6 minus 2 is 4. Don't forget that 1 there. 4 minus 1 is 3. So we simplified that first part. Now, oh boy, Hardy, what the heck? What is that minus doing and how do I deal with it? It's a good question. And here's the answer. If I asked you what 18x minus 10x was, what would you tell me? 8x. This is the same idea. These are like terms because they both have m to the 4th and n to the 3rd. We're not adding exponents. We're not subtracting. They're just like terms. So 18 minus 10 is 8 m to the 4th, n to the 3rd. I'm done. Ooh. Unless there's multiplying or dividing involved, we're not messing with exponents. So that's the one trick with these that I got to be aware of because that can get a little kooky. So we don't want to get spooked off by it. Same thing with 5. We don't want to get spooked by the fractions. That's not going to be a bad thing. Okay, I got parentheses here with this square. So, okay, Hardy, what do we got rolling here? Well, let's see. 2/3 in parentheses. squared. We don't do decimals. It's been a little while. Math, enter, enter. 4 over 9. And then multiply your exponents. 2 times 2 is 4. 7 times 2 is 14. And over here, yeah, there's parentheses, but there's nothing outside of them. So, to finish this one off, remember, the big numbers, the 4/9 and the 1/6, don't play by little number rules. We're going to multiply them. Oh, not decimal. 2 over, oops, probably should get where you can see me. 2 over 27. Add your exponents on your r's. Oh, right there. Add your exponents on your s's. Fractions don't have to be intimidating. That's what we got the calculator here for. Okay? We just have to know the rules so we can guide ourselves into the right place to be able to get there. All right. Oh, I see. Yeah, that's going to be good stuff coming. Oh, I skipped right by number 4. What the heck? We got to go back to number 4. What the frittata was I doing? Okay. So here you're like, all right, oh, negative exponent. Hardy, what are we going to do? Well, let's see. How do we want to do this? We're going to split for once. So there's 2 ways you can do this. And this is just to let you know. Just jump in on one of these. So multiply the bigs. If I add the littles, 4 plus negative 7 would be negative 3. But I can't have a negative exponent in my answer. And I think we might want to make a note of that. No negative exponents in answers. We just don't want to do it. So here's the thing that drives people crazy. They're like, okay, I got it, Hardy. It's a negative 3. I'm going to flip all this. I'm going to put 20k to the third on the bottom. I'm like, close. But here's the problem. 20 doesn't have a negative exponent. K does. So the 20 hangs out. Only the k to the third needs to flip to the denominator. Okay? That's one way we can do it. The other way we could do this is we could say, okay, so 2k to the 4th, that's all positive, that stays. The 10 is positive, it gets to stay. The k to the 7th is negative. It needs to flip. So if I do it this way, multiply the bigs, and as we'd mentioned first semester, and I'm going to mention it here again, one nice thing with subtracting, here, if you look where the bigger number is at, 7's bigger than 4, so 7 minus 4 is 3, but the bigger exponent's down in the denominator, and I get the same answer. As long as you're following the rules, the order isn't going to matter as much. And that's what I want you to be on the lookout for, things. And so, one more in this area, just to kind of clean some things up, because I want to make sure I give you some time to kind of play a little bit and ask a few questions if need be. So this last one, you're like, 15 divided, whoops, type it in right, that would help. 15 divided by 24, that's a decimal. We don't do decimals, math enter, enter. 5 over 8, okay. We're dividing. Subtract, but remember, find the bigger exponent. Bigger exponent is 12. 12 minus 10 is 2. So that 2 goes where the bigger exponent is. 4 minus 3 is 1. 4 is bigger than 3. That goes up there. That's why that's x. Nothing else I can do. That one's done. This is the kind of idea we're trying to get into. Just working on some detail work and kind of seeing how this goes. That was the hard part of what we're doing today. There's one small part left, and then we're cutting it here. We're going to kind of split this first section in two. And so, and if you ever want to do other examples and check them, I'll post those online too. I'm going to post a notes section this semester to try and help out with that as well. But let's just do a couple of quick, easy things here on the back. It's a little Algebra 1 review that we're doing today. So we don't want to do anything too crazy. I am not worried about creating a monomial with quotients of this. I mean, do I want to do that? I'll show you an example of one, just because. So when we get back here, give an example of a monomial with a quotient of this. You're like, well, what does that mean? It means come up with a question that this is the answer to. Like, well, how am I going to do that? Here's the way I like to do it. I'm weird on stuff like this. So I'm like, okay, somebody name me two numbers that if you divide them, you get 3.
15 and 5.
15 and 5. Okay. So negative 15 divided by 5 be negative 3. Okay, I got the number part taken care of. Give me two numbers that subtract to get 2. 6 and 4. So since I want my 2 to be on top, I got, oops, except that's supposed to be n, Hardy. N. Because 6 minus 4 is 2. So I did that. Okay. One last part. Two numbers that subtract to get 1.
So 2 are subtracting 1.
Yeah.
10 to 1.
Okay. But we want the 1 to be down here. That is a monomial with that as a quotient, because if I did the division, negative 15 divided by 5 is negative 3. 6 minus 4, bigger exponent on top, is 2. And 11 minus 10 is 1, bigger exponent on the bottom. I just did a problem backwards by multiplying and subtracting. I undid what I was thinking. And you can do that with any numbers, which is why we're just kind of throwing numbers out there. So if you ask to think a little deeper, maybe sometime, you don't have to skip it. Just think about it for a second, okay? Almost there. First day patience, I love it. Okay, polynomial. Oh, poly, many. The sum or difference of many monomials, okay? The highest exponent, we talked about this first semester, is called the degree. So when we're doing that, okay, standard form just means do your exponents largest to least. You're just putting in order by the exponent. Everything with that monomial goes with it. You're just adding things up. Now here's where this gets a little interesting. Okay. Write the polynomial below in standard form. Okay. So I look through here. Which term's got the biggest exponent? That first one. Okay, so negative k to the 5th. Okay, check, I'm at 5. I look, is there a 4? No. Is there a 3? Yes. Is there a 2? Yes. And notice I'm taking everything with it. The number in front, the sign, everything. Is there a 1? Yes. And we always finish up with what's called the constant term, which means there's no variable at all. Biggest to least. Now, this is where it gets a little more interesting. Because now we've kind of got to make a decision on what variable we're going to have take precedence. So here's what I mean by that. Like these have A and B. Well, how the heck do I make up my mind on what I'm doing? So let's say we decide we're just going to go with the first letter. So we're going to go with A. When I'm looking at these, I'm looking strictly which has the biggest A exponent. Well, this one does. So 4A to the 3rd. Okay. Now, where's the next biggest a exponent? Well, this is. All right. And then that would be the next one. And this one, since it doesn't have any a's, would go last. Typically, you're going to use the first letter in the alphabet that you see on those to make that determination. So like here, X is the first letter we would see. X is what we're going to use to decide how we're going to do this. So I look. X to the third, is that my biggest X? It is. So the whole term comes with, even the Y. Don't lose any part of your monomial. You're like, okay, there's an X squared. Because again, X is what we're focused on. So X to the third, X to the second, X to the first. Well, now what? If something has a variable, that comes next. So Y is the next variable term. And then if I have just a plain old number, that always is going to go last. So that gets a little weird with the multiple variables, but we always just go with whatever variable would come first in the alphabet. And that's going to be our determination. And so the last thing we are going to play here is a little vocab to wrap up. We're in a little bit of a hodgepodge on this first day. It'll clean up quicker as the week goes along here. So this last piece is classifying. They have fancy names for all this stuff. So we name them by the highest degree and by the number of terms. So we got to get a little bit of info over here. So I'm just going to get you a little info. So if something is a degree 0, it's a constant, which means there's no variable. So it'd just be a number like 6. Okay. Once we have variables, you've been dealing with linear, just plain old X, for a long time. We also, first semester, got a preview into quadratic. That's a squared term. So that makes the parabola. Now these last three, and then the mathematicians got smart and stopped making up names for stuff. Cubic, like when you cube something, you take it to the third power. So that one usually makes sense to people. They're like, okay, that one I can handle. It starts to get a little weird then, but we're still going to be able to do this. Quartic, I tell people, think about quarter. A quarter is a fourth of a dollar. There's 4 quarters in a football game or a basketball game. Easiest way to remember that. I don't have a good one for the last one. And it's so close to the last one. Quintic. Quintic and quartic sound the same to me. And that's a 5th power. And then, like I said, the mathematicians got smart and said, we're just going to say polynomial of degree 6, polynomial of degree 7, and we're not going to have fancy names anymore, which I'm appreciative of. So the degree will tell me, like on this one, this number 1, since my degree is 1, so that's the biggest exponent I see, this would be linear. Since the largest exponent I see here is 5, that would be quintic. Okay? Now, the other piece of this is figuring out how many terms you're rolling with. So here, when we're rolling with number of terms, we've just been doing this. If there's only one term, if there's no plus or minus at all, that's going to be a monomial. There's only one term. Bingo. Binomial, bicycle. Okay, 2 wheels. 3 terms. We got a trinomial, like a tricycle. So see everything back to wheels here. And then again, they got smart. Anything 4 or more is just called a polynomial. We don't have fancy names anymore. I kind of wish they'd have figured it out that quick with the other ones. So up here, I have 1, 2 terms. So this is a binomial. Well, how do I know that, Hardy? Terms are always separated by plus or minus. So once you see a plus or a minus, a new term is started. So like here, there's a minus, there's a plus. 1, 2, 3 terms. Quintic trinomial. So I'm going to do something. I'm going to take a risk here. I'm going to freeze frame for just a moment. We haven't done this yet today. We got to do it once. Number 16. Of course, he picks the biggest one. Number 16. I want you to name it with both terms and see. I hope I froze it. Okay, I did. Can you get both names that we are looking for on that one? Because this is going to be our final example of the day. So give your 2 names a shot there. We'll unfreeze in a minute, get down to what we need to do for a little bit of practice. We'll have you ready to go. You'll have survived day 1. Baby. There we go. Our biggest exponent was 3, so it's a cubic. Right there. And since I have, there's my pluses and minuses. I have 1, 2, 3, 4 terms. And if we have 4 terms, we're just calling it a polynomial. Nothing fancy. Nothing fancy. So that's kind of our overview of what we were looking at here today. So, practice-wise, we're going to keep this simple. So here on day 1, we're kind of going splitsies. So here's what we're going to do. So in the practice for day 1 here, we are looking at 1 through 12. This one, 1 through 12. And as I've mentioned before,